Hi, welcome to the Linux channel. See, quite a while ago, I shot various video episodes or mostly a video series on kernel's proc file system. I did various samples, various episodes, as you can see, covering about various aspects of proc file system. In one episode, I covered about how you can read a proc file system or create a file which you get a read access, and then another episode on how do you do a write access and then create a directory in the proc file system and stuff like that. See, recently I'm getting queries that I'm not getting this code executing. I have issues in running this code. Sometimes I get as YouTube comments. Sometimes I get as let's just play this video. Let me pause here. So mostly if I check some comments, you can find that people do often ask that I'm testing and the code is not working and stuff like that. See, like I always mention, with the kernel programming is always you may find some sample or reference code, but the time you test that reference code in your Linux install, your Linux install may be a much recent version versus the code you get is a much older version. So I thought in this episode I'll do a live code port, and this port even I need it for my own official use also, because I thought let's just add some proc interface with respect to whatever kernel stuff I'm doing in my office. I just thought anyway I can do I can do a live video capture as well, so we can do a live code port of this old kernel proc file system code to a newer kernel. So as you see here, this code is released on 2017. By that time it is a very old Ubuntu install what I had. So by the date of that I can say that the Ubuntu install what I had is 2016 October 1. So it is 16.10 is the Ubuntu version mostly installed in my system while I was doing this code, because as most of you guys are aware that Ubuntu releases on in the month of April and in the month of October. So this is before the month of April of 2017. So the Ubuntu should be much older release, and so the kernel version as well. So as a part of that, I have even covered one episode shot a while ago. As you see here, this episode is shot on it's on 2021, and then once again I have a hunch that even the port what I did for this episode is again not working on the more recent kernel version. So what I can do is I can download this code, and in case if you are interested, I highly recommend you can watch this episode as well. This I have done a live port of this code, most probably this first episode code, and into this kernel version of this era actually. So I can do quickly, I can just run this episode. Let's see what is the kernel version which is been attempted actually. So yeah. So hopefully if I list over here, I should come to know. Yeah, but by the look of it, if it is 3rd March 2021, it should be Ubuntu 20.10, so something like that. So this itself is again fairly old. So I'm not sure I'm doing a uname -r in this episode. So nevertheless, we can download this, and we can see if this works with that recent kernel. So let's just quickly download the same. Yeah, so we download the same, and hopefully we should able to 231 and 231 example, and yeah, so let's just do a clean and do a make. So we get some minor error, as you can see here, missing module license, but other than that I don't see any issues in terms of the kernel code. Okay, so we can add that anyway. So yeah, we can just add that anyway, it's quite easy. Let's just go here, backups, test, set as base, and yeah, this is the code. So usually in the past I never add any signatures and stuff like that in my kernel modules, so perhaps we can add the same, and this should fix, because the current kernel is set in a way that even if there are any warnings, it will show it as an error, and you are forced to correct all your warnings as well. So if there are any typecasts or anything is missing, then you are supposed to comply and then compile your kernel. So what we do is we just add that licensing stuff. You can take a template from anywhere. You can take any kernel module which is existing. So let's take some sample driver. Let's take some kind of sample driver, say this watchdog, and this looks pretty big. Let me take a driver which I am aware of. So what is that? Net, Ethernet, Intel, yeah. So let's pick this driver, and we will find that module license or the signature. So as you see here, you have this module description, author, owner, and stuff like that. So possibly you can copy the same, and you can add over here, somewhere over here. Hopefully this should be sufficient. Module description, yeah, they have done this hash define, so we can directly add this description as it is. So module driver description, we can just add, instead of that we can just add a sample proc read access file, and then copyright. You can insert something like this, copyright, something like this. So it's not any range, I am just going to put 2022 and GPL v2, whatever it is, and author I can say my name, something like that. So hopefully that should fix. Let's do a quick make, and you can see there it must have generated this kernel object, okay, or the kernel module. So we can quickly do an insmod and we can test. So before that I'll just grab this debug tail -f where log kernel logs. So sudo insmod proc example.ko. So let's just insert this module, and as you see here, it is not showing any errors, and moreover I am not displaying any debug or anything like that. So you can see there, and we should get that proc file. So cd proc lh, and you can see there the proc file has only read permissions for all users. So cat this, it's going to display in binary because I am giving it in the binary. And this is again many viewers comment saying that how I can do with the string and stuff like that. If you want to output any string data, you can just comment this. That is why I provided like this. You can just comment this and you can enable either of this line, and then the return statement you can do strlen of that string buffer, okay, instead of this the static binary data. In this case I am doing a binary data. So as you see here, I am just copying or mem setting this pattern to this buffer, and it is strictly 10 bytes, so I'm just returning those 10 bytes without doing any strlen or size of stuff like that. But if you wish, you can do something like that. So anyway, since it is binary, the cat equivalent of binary file is xsd command. I was very surprised where many viewers are not aware of this command. So you can do an xsd and a tlc proc, and it is going to show the binary data. So as you see here, it is showing those 10 bytes. So it's 1 2 3 4 5 6 7 8 9 10, yeah, 10 bytes. And yeah, with that it generally works. What I can do as a quick add-on is we can also download this previous episode's code, and we can do a diff and we can do a compare, because luckily in this episode I don't have to do any changes in the APIs and the C code. Okay, so which is good that we don't need to change, because I thought of my colleague to pick this code and do some debug in our kernel code. But before that I need to check whether this is going to run or this is going to work as it is or not. Okay, because these days actually I am not doing it, it is my colleague who is doing it, and I generally do assist him and stuff like that. So what we do is we can quickly download this previous code, and as a small add-on for this episode we can do a quick diff. So we go back here and extract 191, so that's the episode number, and we can do a diff. See, you can do a diff via this command 231 example proc example.c and 191, or it is in this folder proc example.c. You could do a diff something like this, or better you can use a tool called compare. So this is similar to a tool called beyond compare or something. You will get it in Windows. Okay, so you can use a tool called compare. It's compare because it is a part of KDE tools. Okay, so compare, and then you can type these two file names. I'm going to put old one first and the new one next instead of this order. So this will highlight what is existing, what is added. Okay, so we do a diff like this. See, you can see there the code is 22 Feb 2017 versus the code is much recent, it is 2021, and I have just added these release notes. What I'm going to do is I'm going to take this source code and I'm going to add further some more release code saying that, or stating that I'm adding this license details actually. Okay, so you can see there in this case there is a huge change has been done versus the older version. In the older version we have the static struct of file ops or the file operations, and this is the fops, versus here I'm using a different data structure. And you can watch that episode. See, the way you can understand, or the way you will come to know how to change these things, is you can go through an existing kernel source and see that how things are changed, and then based on that you can port your code as well. This is one thing again beginners don't understand. They always search in Google and find some random code and they try to just compile that code and try to make use of that code as a part of their kernel programming experience. But that is a pathetic way of approaching things. The reason is that code must have been done ages ago for some old kernel, and it will never work. And you may think that you have done a mistake, why things are not working at your end, versus the guy who posted the author who posted that sample code has been done that way. But the thing is, his kernel is quite old, must have worked with this kernel, but it is not necessarily going to work with your kernel, because the APIs must have got changed, the name of the APIs must have got changed, or the arguments have got changed, or even the internal data structures and stuff. So this is a classic example. You can see there's a data structure called file operations which is replaced with this proc ops. okay. And you can see that the rest is looking almost the same. Here I am doing as a owner this module. Here it must have got removed. Most probably it may not be even required actually. So you can see there proc read, and this API has been passed. So after that you can see below there are not much any changes. This is the one which I just added now. So that's all it is. Okay, something like that you will find always. Hence any kernel code you take, understand if it doesn't work, just try to port. And this is again, like I say, it is quite easy to check how it has to be approached, which I have already discussed in previous episode. But this episode, in case if you watch, I can give you a quick tip. So this is the standard API from the kernel proc create. So copy this, and what you do is in the kernel source, let's go back to the kernel source and search that API. Okay, so search that API or some data structure, and as you see here, this is where the API has been defined, proc create and blah blah blah, all that function arguments, and you have various other APIs surrounding that API. As you see here, proc remove, proc create. So this is the API pairs. You see there, remove proc entry. So again, so what you do is this is the API, and if you go somewhere .c file, you can find the implementation of this API obviously. So let's open this. Okay, it is coming as a part of file system because proc itself is a part of your kernel file system. Okay, and it is going to provide the same abstraction as any other file system through VFS or virtual file system. So you can see there it is under the file system proc, and so files are there. You can go back again here, see this is under the proc, and you can go back here, you can find all this various file systems. So we go back again to that proc create, and you can see there this API is a wrapper API which is calling some other internal API. So every time this happens, this is called as wrapper API. Okay, so this is what is the actual API. So proc create data, you can see there, this is a this can be sometimes a static one, which means it is not exposed to the outside. So you cannot use or call this API directly in your code. Instead you need to call through this wrapper APIs, which again making sense because here you can see that proc create is the API which has this export symbol put. So hence this API is exposed for external use. Okay, so this signifies, okay, again this is something you find common in the kernel code but not necessary in your C projects done in the user space. Okay, so as you see here, if you see this code, it is doing so and so and it is doing that stuff. And as you see here, proc register, and again this API is calling another API, and that API may do subsequent required stuff. So hence go back here, what you do is you see all these references of that proc create, which means these places that API is getting called, and they are trying to create a proc file of various other kernel modules. So what you do is take any example randomly and pick a code which is easy to understand and a simpler example. Don't pick a difficult one where you cannot much understand. Okay, so you can see there, pick something which you can easily understand. You can see the proc create. So they are doing this way, they are passing that file name hopefully, and that we can cross check with my code as well. So this is the file name and the permissions, and in this case they are doing this permission in this way. So either you can do this way or you can directly pass the permissions like you do with the chmod command. Okay, so if you are interested to pass this way, you can again check this data structure. Okay, it is some sort of enum or hash define going to be. So as you see here, it is some sort of hash defines. So in this place, if you see the file operations, you can see there the file operations are over here, and as you see here, fops are being passed this way. The data structure is passed to this proc create in this method actually. Hence you now get a hint that okay, how this file ops data structure has to be used and what is the current data structure. As you see here, this is the proc ops. Okay, hence I'm also doing in the similar method. Hence my code is in compliance with what is expected in this version of kernel code. Hence you see here proc ops, and then these are the FOPs, and this is what I'm passing. I'm only supporting the read access, hence I need to populate only the read access API, which is this read API, which is TLC proc a underscore read. So in this case they are populating all other access, so they are doing some sort of seek and other stuff, so hence they populate these APIs for this proc read, proc write, and various other operations. Actually in my case I'm not doing it, it's a very simple example, so hence I'm not doing that. So this gives a hint that how you can port your some non-working code of kernel into a working code of the current kernel. So sometimes if the code is small, you can port it quite easily. If the code is quite complicated, then it is very difficult. So as an example, see, I did this compare, right? So in this compare, you have this struct file operations data structure, which is replaced with this proc underscore ops data structure. So what we can do is we can check if this data structure is still existing in this modern Linux kernel. So this is file operations. So let's search file underscore operations in the kernel source. So and see that if such a data structure is still there. So we can see there struct file operations is there, and we can also figure out what is the reason it is not being used, or what is the reason when I do this way in the modern kernel it is throwing the error. And in case if you are intrigued, we can actually do a quick check. Okay, so what we do is we go to this older version of the code, proc example. See, if you see here, this is the 191 and proc example. This is the tarball I expanded, and this is the folder I got. So we go here and we try to compile this. Okay, and as you see here, it is showing this error, and it is saying that something is not compatible. So that's what is the error, and this is what triggered me to go and check how the things are done in this recent kernel, and hence the porting I have done live in that episode. Hence you have this newer episode of this older episode, and this episode is all about porting my code from this old one to this new kernel. Unfortunately I could have put some kernel version new, in the sense which kernel from what kernel it is working. Unfortunately I have not marked there, hence it is quite difficult to track this thing. Nevertheless, anyway, from the release date of this video one can guess what is the overall thing happening. So you can see there is still this file operations is existing, but we can search these references how it is getting used. Okay, so we can see there is there anywhere it is still getting used. In this case you can see their file operations are there, and in this way it is there, and we need to see the FOPs have been defined this way, and we see if the proc create is able to register this FOPs, which is perf FOPs, and we see if that perf FOPs have been passed. Okay, so this is the file operations data structure instance, and you can see it is not being used along with proc create in this example. So unfortunately this is not useful, so let's go and check some other example in this list. So we take some other example, and again there is this, but again in this case also this is an FOPs, but it is not getting used. So what I am seeing is nowhere I am seeing any proc like use case it is getting used. So perhaps the data structure is there, but when it comes to proc file creation, perhaps they are expecting a different type of data structure. Again, it is quite easy to understand or get a guess, because you search this proc create API. Okay, we do a difference between modern kernel and the older kernel, and you see there proc ops, you see there the data structure it is expecting is this proc ops, but it is no longer expecting that this older one, which is file operations. Hence it is not the way you need to pass it in a modern kernel. So once again we can do a comparison between this version of kernel. As you see here, this is the proc create, and the data structure it is expecting is proc ops. So we can go here and we can select this is the file proc fs, and we can select a older kernel, say version 4, some kernel in version 4, and let's see how they are doing over there actually. So this you can see there procfs.h, but it is from the version 457 kernel, okay, 4.5.7 kernel. And let's search for proc create, and you see there in the proc create it is expecting the data structure as file operations. It is no longer that data structure is there. And if you are confused, we can still go back here and maybe it is, we go back here of that 457 kernel and see or verify if this API is ever defined actually. So proc underscore ops, so we search here, we search in this, okay, such a thing is there. So I'm sorry, I'm in the latest kernel. In this we can search proc underscore ops. So looks like it is something there as a reference, but I'm not sure that is this actually. Yeah, as you see here, this is not a data structure. In this case it's just an instance actually, so it's not a data structure, so it is a file ops of this, so that's not a right match. So as you see here, it has never been defined as a data structure like you get it in the modern kernel source. So the whole thing must have come sometime recently, and then they have added this whole code. Hence the reason it is very common, take any kernel module and or driver or something, you take it from some example or you take it from GitHub or somewhere like that in some random source, and you try to compile, and you will be often finding this issue that it is having an issue in terms of compilation or something. One easy hack is, although instead of compiling in your modern kernel, you can install a Ubuntu or any distribution of that era, okay, when the author published that code, if it is done on 2015, you can pick something of that era, an old Ubuntu LTS or something you can pick, and then you can attempt in that distribution rather than a modern current distro access. So this way you can at least make it work. But other than that, when it comes to forward porting, okay, when you port it to modern kernels, it is from older code to the newer kernels, it is called as forward porting. When you do porting of newer code to older kernels, it is called as back porting actually. So if you want, you can do a forward port or back port based on your requirement. So this is quite important for especially a newcomer or anybody who is just somewhat started getting into kernel programming but still not well experienced actually, because the moment you take any kernel module sources from some random places in the internet like GitHub or anywhere, you will get this problem often. See, often I don't publish my code in GitHub, I put it in my own hosting server as a tarball something. So but again, you often find any such thing in a sources like GitHub. So if you find anything, you have to forward port or you need to back port depending on the relevancy of that code. If it is too new, and if your kernel is old, you need to back port, and in case if it is the kernel is too new, then you need to forward port. So I'm going to add a small note over here as a release note and updating a date, and of course I may create a new tarball with this episode number and stuff like that. So what I can do is I can just add this note. It is on April 28, and release note added the module what is that, module license and metadata. So something like that. It is just a module metadata, right? So you can just add it, and usually you can put this anywhere. I kind of see them people putting over here, but I feel that it is somewhat annoying that after you see this all these include files, I tend to see all these global variables which are defined over here rather than something like this. So I want to put something stuff like this at the end rather than at the beginning, okay, because this is just a metadata, you can put it anywhere. So I can do a quick sample compile once again, and then if it is ready, then I can yeah, so let me go back. It's the episode 231, and I can do a clean and make. Yeah, as you can see here, it compiles just fine, and we can also attempt something to trigger any warning, okay. So I just want to do something to see how the current kernel modules yeah, say for instance percentage %s, percentage %d, let's do some sort of integer variable, say a, and yeah, and say let's define it as say char a, and we see that how it is going to work with any module warnings, okay, compilation warning. So let me just do an rm mode proc example something sudo rm mode, yes, and let's do a sudo int mode proc example .ko. Yeah, I'm sorry, I need to recompile. So let's do a make again and see that how it is going to. It's not showing any error. Maybe percentage elu long unsigned. Yeah, so warning. So let's just do a clean and make. Yeah, as you see here, it is not, it is throwing it as almost as this warning. So you can see that this is just a minor warning, as you see here, but nevertheless it is able to compile. But generally these days, if you write any serious kernel code, it is highly recommended that you also address all the warnings, because if you compile this as a part of complete kernel compilation and not a module, okay, in case you add any kernel code in existing kernel, let's assume that you are adding some code over here as a part of entire kernel and doing an entire kernel build. So in that case, if there are any warnings, and obviously it's just recently done in such a way that all the warnings also is considered as errors most of the times, and unless until you address these warnings, it's not going to compile it further. So keep a note, and I can even point an episode where there is a mention in Foronix website. Okay, we can search as kernel warnings as error, something like that, and hopefully we will get that news article. Yeah, as you see here, enabling -w error by default for kernel builds. So this is very important, and this even my colleague have encountered, and I told him to address all the kernel warnings, because it is never going to complete your kernel builds unless you address all this kernel warnings. In this case, perhaps since just this is a module, perhaps it is accepting, or perhaps we can add that feature over here. So let's say we add that option with that make over here, hopefully somewhere here, hopefully it should work, I'm not sure, because usually we add it with the GCC, I'm not sure with make how to add. So let's do a make let's say clean make. Still it is doing it, perhaps this is not the way to do. Anyway, so usually this is a GCC option, but I'm not sure. Anyway, nevertheless, since it's a module, at least it is compiling, but if you are attempting any serious kernel build, it's never going to work that way. So let me do a cleanup, and I can again bundle this source code and put along with this episode, so that you should get a thing able to compile, and it should work out of box. Okay, so let's just do a clean and make. I'm not generally a fan of populating the make clean and stuff like that, hence I will keep always a separate clean script. This I generally do, let it be user space or kernel space code. Okay, so yeah, so it is generated. As you see here, there are no warnings. See, just a quick note, the kernel I'm working on in this current system is this, as you see here. So what I can do is I can just add this as a metadata, and as you see here, I created this folder, and the next episode is going to be 249. So I can just add a note saying that it's compatible with Ubuntu kernel. So this one is Ubuntu version software and updates. So this is not the one. This is updates live patch. So let me see. This is impress. New name minus a. Ubuntu. Let's just find Ubuntu distro version name. LSP release minus a. Let's try this command. It's Ubuntu 21.10 Ubuntu kernel, Ubuntu 21.0. So it's a part of that kernel, and it is the 41st iteration actually. So this should be good enough, and this is a part of episode 249 actually. So this way you can see there it's keep getting tracked. In case in future if there are any other changes, again I am going to do a porting video, and that way it will be always, you will have a historical record of how things are carried forward. So hope you learned something new in this episode. As usual, if you have any questions to discuss, feel free to discuss with me in mail or LinkedIn or WhatsApp, whichever platform if you wish, or if it is a very small query, we can of course discuss in YouTube comments as well, because we can't share any screenshots. Sometimes I even tend to send any screenshots and stuff if I get any queries, but we can't do that extensively with YouTube comments. So I still recommend, if you want to discuss, you can discuss freely in a mail or any such platforms. Hope you like this episode. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.